Problem number 15. We've got the function f of x, y, z is x squared plus y squared. D is the region that's inside the sphere. X squared plus y squared plus z squared is equal to 16. It's outside the cylinder. X squared plus y squared is equal to 4. We're asked to express the triple integral over D in spherical coordinates. Okay, so we want to change everything to spherical coordinates. This right here is going to be rho is equal to 4. So this is rho squared is equal to 16, so rho is equal to 4. Rewriting this in spherical coordinates, let's see here. X squared is rho squared cosine squared theta sine squared phi. Y is going to be rho sine theta sine phi, so y squared would be rho squared sine squared theta times sine squared phi is equal to 4. Let's see here. These two terms on the left both have rho squared sine squared phi in them. Rho squared sine squared phi. And then this has cosine squared theta. This has sine squared theta. So it would be rho squared sine squared phi times cosine squared theta plus sine squared theta. The sum of those is 1. So this is just rho squared sine squared phi is equal to 4. If we can take the square root of both sides here to get rho sine phi is equal to 2. We're allowed to take the square root here because rho won't be negative. And for the values of phi that could potentially come up, phi, the natural bounds on phi are between 0 and pi. Sine of phi will always be positive in that interval. Okay, so this is going to be our, we've written down these bounds here in terms of rho and phi and stuff like that. Let's get a sense of what this looks like, and I guess, let's just remember our goal here is that we want bounds on theta and phi and rho. Okay, so this is region inside this sphere. This is the sphere, rho is equal to 4. But it's also going to be outside the cylinder. So, try and find a non-black marker to do this with. So there's some cylinder here. So we're taking a look at that region over there. I mean, there's also some around that goes all the way around. So first thing we see that this is radially symmetric in terms of the projection to the xy plane polar coordinates. So this says, hey, there's no theta dependence going on here. Theta is going to run from 0 to 2 pi. As for phi, let me just draw the projection of this region into the YZ plane. So if we take this and look head on from the positive Z axis in the YZ plane. So the projection of the sphere looks like a circle of radius. This is going to be the rho is equal to 4 circle, so that's 4, negative 4, negative 4. And then there is going to be the projection of the cylinder into the YZ plane is going to be a rectangle here. And so the region that we care about is this region right here on either side. And of course, take this and rotate this around and rotate this back. You know, it's not a disconnected region, it's a region with a hole in the middle. Okay, how do we find what phi is? Well, phi is the angle we make with a positive z-axis here. So we don't pick up phi as equal to 0. We pick up phi starting at this angle. So there's be like phi 1, and then phi runs from here until we hit down here. This would be our phi 2. How do we determine these phi values? Well, these are the intersection of the two shapes we have going on here. These are the we have these points here. Rho is equal to 4, and rho sine phi is equal to 2. So let's solve these equations here. Rho is equal to 4. 4 sine phi is equal to 2. Divide by 4. Sine phi is equal to 2 fourths. That's 1/2. When is sine phi equal to 2 1/2? Well, that's phi is equal to pi over 6. Or that's phi is equal to 5 pi over 6. And guess what? That corresponds to our two phi bounds here. So pi over 6 to 5 pi over 6. How about rho? The biggest rho can be is 4. And the smallest rho can be, for a particular value of phi, has to do with that, with the surface of that cylinder right there, which is coming from the rho sine phi is equal to 2. So we divide both sides by sine phi. Rho is equal to 2 over sine phi. And there's all of the bounds that we need. So we can write down our final answer at this point. So what do we end up with? We have the integral theta runs from 0 to 2 pi, and phi runs from pi over 6 to 5 pi over 6. Rho runs from 2 over sine phi to 4. Okay. The integrand is going to be x squared plus y squared. We already figured out x squared plus y squared is rho squared sine squared phi. And then we should know, because we're converting to spherical coordinates, we always have the factor of the Jacobian thrown in there. Rho squared sine phi d rho d phi d theta. And so this is we're just asked to set up. We don't have to express this. So this is our final answer.